Hi everyone, and welcome to this course on databases. I'm sure that if you look around, you will see huge amounts of data in every company or work, and databases are actually a great way to store this data. For example, if you are making a website or an application for Android, it will definitely rely on a database, which is running on the back end. That's why it is really important for you to know how to implement databases, which is what we will learn to do in this module. The module is divided in two major themes. 1. Database design, and 2. How to implement database design. What is a database? So first, we will explain what a database is. Now, a database is an organized collection of data. The data is typically organized to model and mirror aspects of reality in a way that supports queries requiring information. Some examples of databases in your daily life would include library databases, WhatsApp friends list, college teachers list, etc. Such databases can be handwritten in notebooks, for instance, that would compile the data. But more and more often, the data is stored in a computer software. Computers are an excellent electronic device to store data, because with a computer we can easily manage and transfer the data. We can also search and retrieve the data very easily, because computers work faster than human manual work, and computers also ensure consistency. For example, Amazon also manages and saves data of products, customers, sellers, and customer reviews information in a database. They are managing big websites, and it is crucial because their website revolves around data, and their main concern is that data should be easy to manage and retrievable so they can serve their customers in a better way. When we talk about storing data in a computer, it doesn't mean that we can save data by only one method. On the contrary, there are many ways to store data in a computer. For example, it's even possible to store data in a text file, Word or document, but these methods are not the most efficient. All databases are based on one language, which is SQL. As you know, SQL is Structured Query Language. We have already seen how SQL is really a standard in the developing community. But all database management system providers implement it according to their convenience. This means that the query of one management system will not automatically work on another management system. There is a possibility that their syntax as well as features are slightly different from each other. For example, there can be one system where the security of the management system is high, another one where management has backup features, and a last one that has a system that supports applications. The point here being that even if systems use the same SQL language, you can still expect minor differences in how to operate them. If you are a beginner and learning SQL for the first time, I would still say that you can basically choose any DBMS. It doesn't matter in the end. The main thing is that you will learn SQL, and SQL's design and basic concepts will remain the same in all databases. So, even if you spot minor differences, don't panic. This is normal and will not affect your knowledge of SQL. A last point of vocabulary before we move on. When I talk about a query, I mean a command or an instruction which we will write and pass to the database management. And then the DBMS will interpret the command and then run it. In this section, we will discuss the difference between SQL and MySQL. Number 1. SQL is a language that is used to operate your database, whereas MySQL used to be one of the first open source databases available on the market. 2. This means that SQL is a database language, whereas MySQL is software. 3. More specifically, people use SQL to sort, manipulate, and retrieve data in a database, whereas MySQL is an open-source RDBMS, Relation Database Management System, that focuses on allowing the databases to manage relations. 4. SQL doesn't change the language of a database, whereas the software can. Quick reminder, since MySQL is a software, it needs to be updated frequently. 5. SQL codes are used in Oracle and MARIADB. These are examples of databases, and the link between SQL and MySQL is that MySQL actually uses SQL language. 6. MySQL as a software supports multiple programming languages, including Java, PHP, VB, Delphi, Go, Python, Ruby, C++, and R. Basically, all the programming languages that are supported by SQL servers. Furthermore, MySQL supports some additional languages including Perl, Scheme, Eiffel, TCL, and Haskell. This makes MySQL very popular among the developer community. 7. SQL is a query language, whereas MySQL provides an integrated tool environment which is called MySQL Workbench. The MySQL Workbench allows you to design and model databases. 8. SQL does not provide connectors to build database application, whereas MySQL does. MySQL can provide database drivers for the .NET platform, C++, Python, and Java. So now that we've seen what makes SQL and MySQL different, it's time to talk about their significant similarities. First, they are both relational databases. However, it's important to note that most developers will specialize in one or the other, rather than mastering both. Thus, and although MS SQL and MySQL appear to be identical, their fundamental design is not. Here are several parallels to be aware of. Tables. Both platforms store data in columns and rows, using a typical relational database table format. High performance. MySQL and MS SQL both provide high performance speed, which is very important since your database serves as the backbone of your applications, storing and delivering data as rapidly as possible. Both systems can thus be trusted to match your needs. Keys. Primary and foreign keys are used by both systems to construct connections between tables. Web-based popularity. Because of their many qualities, both systems are very popular online. With the exception of Oracle, the most typical databases to use for web applications are MySQL and MS SQL. When you sign up for hosting, you're normally offered the choice between MS SQL and MySQL. Scalability. Both systems may expand along with your business. They are appropriate for both small and big applications and can handle millions of transactions each day. Their scalability also makes them very attractive. Syntax. The syntax of both platforms is similar, although you should expect some small differences across varying CRUD, create, read, update, delete statements. Native compatibility. SQL Server was originally developed exclusively for the Windows operating system by Microsoft. Microsoft has recently made RDBMS available on both Mac OS X and Linux. This gives companies the option of running the database system on 3 separate platforms, Unfortunately, users still lack the option to use certain capabilities while running SQL Server on Mac OS X or Linux. MySQL is better in that regard, as it can run smoothly on multiple popular operating systems, including Linux, Mac OS X, and Windows. Support. As seen previously, both MySQL and MS SQL support the most popular programming languages, including Java, C++, PHP, Ruby, Python, Delphi, Visual Basic, Go, and R. MySQL supports additional languages like TCL, Scheme, Perl, Eiffel, and Haskell. Because MySQL is so versatile in its support for programming languages, it is popular among the developer community. While you can use both database types for Windows and Linux projects, MySQL works natively with PHP, and MS SQL is mainly used with .NET. Integration is simpler if you use MySQL for PHP and MS SQL for Windows projects. Cost efficiency. MySQL is free and open source, although you'll have to pay for support should you require it. MS SQL is more expensive to run because you'll need licenses for the server that is running the software. Backup. Another similarity between both systems is the need to frequently back up your data. However, the way to do so is slightly different. If you're using MySQL, you'll need to back up data by extracting it as SQL statements. The DBMS provides a tool to block the database while you back up your data. This feature minimizes the chance of data corruption occurring while switching between MySQL versions or editions. The downside is that this makes data restoration a time-consuming process because it requires executing multiple SQL statements. MS SQL doesn't block the database while backing up data, enabling users to back up and restore mass amounts of data with minimal effort. However, there are fewer safeguards against data corruption. Binary collections. The final similarity is that MS SQL and MySQL are designed as binary collections. MySQL allows developers to use binaries to manipulate database files, even while they are running. Database files can also be accessed and manipulated by alternative processes at runtime. Conversely, MS SQL doesn't allow any process to manipulate or access binaries or database files. If you wanted to achieve this, you would need to run an instance. This eliminates the opportunity for hackers to access or directly manipulate data. In that regard, MS SQL is more secure than MySQL. Types of databases. There are two important categories of databases: relational ones and non-relational ones. SQL uses relational databases, which has one standard language, and all relational databases are based on SQL. On the contrary, non-relational databases don't use a single standard language. They have multiple languages and they use them differently. Basic difference between relational and non-relational databases. Let's go over the main characteristics of relational databases. They 1. Store data in something we will call tables. 2. These tables consist of rows and columns and will display entities. 3. SQL has a fixed data structure. 4. Relational databases are vertically scalable. 5. They can support complex queries. 6. And finally, they are normalized. Non-relational databases. 1. They store data in any form except in the table form. 2. For example, they could store data in graphs and key value pairs, or they could support hierarchical and dynamic modes of visualization. 3. They can be scaled horizontally. 4. Because of what we mentioned before, it is the best kind of database for hierarchical data. 5. But it is not good for complex queries. 6. Usually denormalized. I'm going quickly over these characteristics now, but we will return to key concepts like normalization in some upcoming lectures. This is just to give you a synthetic overview of the main differences between both types of databases. Database Management System, which is also called DBMS, is a piece of software which is used to communicate or interact with databases. It really just means that we will interact with our database through a database management system. So, if you look at the graph on your screen, you can see that we have our database on the left side connected to our database management system in the middle, and finally our users, software and apps on the right-hand side. Basically, DBMS is our middleman between the user and our database. It allows us to perform any task or run any command in the database and to execute it. Without DBMS, we cannot connect our database to our users, apps or software. Next, we will go over relational databases. If you remember from the beginning of this module, relational databases is one type of database, not to be mixed up with a normal/non-relational database. If you need a refresher on the differences between the two, I invite you to watch the second lecture of this course again. In a relational database, our tables are connected with each other by the source of relationship, which is not the case in normal database tables, which are not connected with each other. They are only linked with each other by using primary or foreign keys. On the slide, you can see examples of famous database systems like Microsoft Server SQL, Oracle, MySQL, and PostgreSQL. Now, let's move on to tables. Generally, tables are used to store data in horizontal and vertical sections. They are called columns and rows. As you can see on the slide, we have sections of books and employees that consist of different fields. I'm naming the columns as field and the rows as record. So, in the first table, the book table, every row, shows the record of every book for which we have data. Each book has its own row of data with its own characteristics. If you look at this table carefully, the first column is Book ID, which appears here in highlighted text. I highlighted this text because it is the most important column of the table. Indeed, this column allows us to identify every row of the table uniquely. In this case, every book has a unique ID number. For example, the book with the title Book C++ has the ID number 1, and the book with the title Java has the ID number 2. The gist of this is that the first column of this table helps us find our way in the rows and uniquely identify the objects of data, books. This is particularly relevant if we had two books with the same name. Indeed, if that was the case, we would use their different ID numbers to know which book has which data. The same scenario can be applied in the employees table. Let's imagine two employees have the same name. Then, their employee ID would allow us to differentiate between them. There is no golden rule that says that we can only differentiate objects with their ID numbers. We could imagine a table where the difference is made with phone numbers, email addresses, etc. But in most cases, we assign an ID field integer, which is called the primary key. So when you study data tables, make sure to look out for and identify the primary key that will help you separate the data easily. Generally, a table represents one entity or subject. For example, on the screen, our first table is about books, and our second table is about employees. One important point is that we will never mix these tables. If we have any real-world entity, we will try to make a separate table and put all the related information in a table. We will discuss in detail which information should be included in a table or which information deserves a table on its own. Hopefully, we will also study normalization, which is the process through which rules are defined on how to design a database. As you can see on the screen, the data in the columns relates to the name of the column. For instance, on our first table relating to books, one column is the writer one. The data in this column will inform us on the author for each book. In the employees table, the column starting with phone gives us the phone number associated to each employee. This is what we call data relationships. There are three basic relationships in a database, which we will discuss right after. Types of relationships of data types. There are three types of relationships in a database. Number 1, one-to-one. Number 2, one-to-many. And number 3, many-to-many. One-to-one relationship. In a one-to-one relationship between tables, one record in Table 1 can only relate to another record in Table 2, and vice versa. For example, as you can see on the screen, we have two tables. The table on the left is for employees' data, and the table on the right gives us the salary of employees. In the second table, you can clearly see that it consists of employee IDs related to their salary. So we can understand that the employee with the ID number 1 has a $54,000 salary, and that the employee with ID number 2 has a $40,000 salary, and so on. Now, let's carefully focus on the observation that each employee only has one salary. There is no employee with two salaries. It also means, reciprocally, that no salary relates to multiple employees. This is what we call a one-to-one relationship. So, one question that some of you may have is, why do we need two separate tables, when it seems that they could both be merged into one without creating an error? This is because both tables clearly give data on the same employees. But there may be reasons for keeping these tables separated. For example, it could be that the company compiling this data on employees wants to make all the information public except the salaries. By keeping these tables separate, we can easily restrict the access to certain information that can be considered sensitive. Or, tables can be kept separate for security purposes. Small bonus. If you look at both tables on our screens, the ID section is highlighted in black. This is what we would call the foreign key, the primary key of a table that became a column in a different table. The next relationship between tables is the one-to-many relationship. As you can see, we have two tables. In a one-to-many relationship, a record of one table will relate to multiple records of another table. We saw this table in the previous lecture, in which I had written the phone number of the employee in the employee ID table. However, one employee has multiple phone numbers. This is a problem because we cannot write multiple phone numbers in the same cell. It violates the Rule 1 NF1. NF1 says that we cannot insert multiple values in one cell. In other words, one cell equals one value. We also call it an atomic cell. This topic will come back in our section about normalization. So, to follow the NF1 rule, we will break the table and make a separate table for employee and phone numbers. Then, we will refer the employee ID to the employee phone table. Now, if you look at the table on the right, you can see the column Phone ID, which is highlighted and represented with a black color. As we have seen previously, it is called a primary key because it identifies every record uniquely. Now, if you see the second column in the same table, we see Employee ID, which comes from the employee table on the left. For example, on the first row, Employee ID number 4 is related to Henry. It means Phone ID 1 relates to Henry, and it is Henry's phone number in the first row or record. Now, if we see that further down the rows one of the employee IDs repeats itself twice, and it is associated to Kevin, it simply means that Kevin has two phone numbers. These one-to-many relationships thus allow us to show the multiple phone numbers of one single employee, which would not be possible in the same table. However, it's key to note that a one-to-many relationship does not work both ways. One record of the employee table on the left can relate to multiple records of employee phone ID table on the right. But one record of employee phone ID table cannot relate to multiple records of the employee ID table. In other words, one employee may have multiple phone numbers, but one phone number cannot relate to multiple employees. That's why it is called a one-to-many relationship. In this relationship, one record of table number 1 relates to multiple records of the second table, and one record of the second table can relate to multiple records of the first table. Now, we will explain this better with the help of the example which is displayed on the screen. If we look at the first two tables, we can say that one employee can have multiple skills, and there can be multiple employees that have one skill. So both tables will form many-to-many relationships here. To represent this type of relationship into a database, we need to create a third table, where we will add the primary keys of the first two tables into the third table as a foreign key. Now, when we want to assign any skill to an employee, we will add the employee ID and then we will insert the skill ID we want to assign on the same row. So one skill can be inherited by multiple employees as well. Now, if you look at the second table on the screen, Employee ID 1 is repeated multiple times. This means that Employee 1 has both Skill 1 and 3, which is PHP and SQL. If we want to see how many Java developers we have, we will check where skill number 4 appears in the skill ID column. It matches Employee ID 3, whose name is Peter. This means that Peter has the Java skill. So, when you will design a database, you should constantly ask yourself what kinds of relationships are forming between your records and your data. If you can easily define the types of relationships, then your database design will be better. To better understand the concept of many-to-many relationships, we will take the example of students and subjects. In this example, a student can follow and study multiple subjects, and one subject can be followed by multiple students. Conversely, if we look at the relationship between bikes and owners, an owner can have multiple bikes, but a bike cannot have multiple owners. What does this mean? If you answer that this is a one-to-many relationship, then you are absolutely correct. So, it is very important for you to understand the structure of relationships between tables of entities. That's it on relationships. In the next video, we will go over the installation of tools that are required to learn SQL. We will also learn about the syntax of SQL, and we will see how to make tables. Until then, take care of yourself. Assalamu alaikum. In our previous lectures, we discussed an introduction to SQL and types of relationships we can have in an SQL database. Now, we will go over the installation of Microsoft SQL. Installation of MS SQL and SQL Server Management Studio. First of all, we will search MS SQL on Google and open the Microsoft website. Then, we will download the MS SQL of Developer Tool. We have successfully downloaded the MS SQL, but before installing it, we have to download one more thing, which is the SQL Server Management Studio. To download it, we will search SSMS on Google, and then open the Microsoft website and click on the download button. This is a bigger file compared to the MS SQL, so it's normal if it takes extra time to download. Once the download process is complete, we will start its installation. As you can see, both MS SQL and SSMS have been downloaded in our operating system. Now, we will install them one by one. Let's start with MS SQL. Click on the Install button, where three options will appear: Basic, Custom, and Install Media. We will select Custom. As you can see on my screen, my storage is not sufficient to install MS SQL in C drive. So let me quickly adjust the space for the installation first. So, I'm selecting the F storage drive because I don't have enough storage in my C drive to install MS SQL. Now, we will click on the Install button. Okay, the installation is started now. Once it's installed, I will give you more detailed instructions. So, after completion of installation, this window will be opened automatically. By default, the Planning tab would be opened, but this is not what we want. We have to click on the Installation tab, and then we will click on New SQL Server Standalone Installation or Add Feature to an Existing Installation. Our installation is started now, and it will take some time. The time it takes also depends on the system requirements, so after the installation, I will tell you further things we have to install. So, after the installation, a small window will be opened and it will give you some options. First, you have to select the Developer option. If you want to use advanced features, you will have to purchase a license for that. For now, we will just use the free edition and click on Next. Then, we will check mark the terms and conditions of the agreement and click on Next. If you want to receive notifications for new updates, then you can also check this option in the Microsoft Update tab. It's up to you. Now, we will click on Next again. It will do some more installations automatically. And after those installations, we will click on Next. At this point, it will ask for verification of the Azure extension for the SQL server. You just have to unmark it and then click on the Next button. Now, we have arrived to the feature selection. We will click on Database Engine Services, because this is the learning objective of this course. Click on Next again. OK. It will give us option to use default name or custom name. We will select default name for now. But when we will make any new server, we will change its name. The next step will give us server configuration. It will give us two authentication modes, the Windows authentication mode and the password mode. For now, we will select the Windows authentication mode. Then, we will select one user and click on Next. OK, after all of this, I think our installation is about to end. After completion of the installation, a small window will appear, and it will ask us to restart the computer for better processes. But for now, we will cancel it. Now, let's install SSMS in the same place where MS SQL is installed. Our installation is started now, and the installation of SQL Server Management Studio is completed. You can also repair it if you are facing any issue. Now, you just have to click on the Windows button and search for Microsoft SQL Server Management and click on it. Management System will be opened. Then, the interface will appear. As you can see on the screen, I already made a database with my name. All our installations are complete now. We have also learned what elements a database has and how to open a database. When you will install SQL, a small window will appear. There, you have to write your database name. You choose. It can be any name you want. Because I have chosen the name Muhammad Munib for my database, a server with this name is opened on the screen. Now, let's create a database. Click on the Query button, and you'll see that a new tab will be opened here. Before we run anything, I want to specify that SQL is not a case-sensitive language, unlike HTML or JavaScript, in case any of you are familiar with that. Now, we will run the query create database books_db and press the refresh button. We now have a database with the name books_db. If you had used master, then it would appear in the system database folder. But I did not target any other thing and used a simple database. That's why it's appearing in the database folder. Now, let's create a table in it. To do so, click on books_db database. Let's open the tables folder. That's where all our tables will appear. Now we will run query. ID integer will be our primary key, and then we will enter the first name and last name with varchar characters. Now, if you have learnt MySQL, you will see similarities here. But as we've seen in previous lectures, SQL and MySQL are not totally similar. There are differences between them. Now, we will select year and add integer, because we want the year in numbers. The code is the following. Create table books, open brackets, ID int primary keys, name, varchar, open brackets, 30, close brackets, last name, varchar, open brackets, 30, close brackets, year, int, close brackets, semicolon. Now we will execute the query. As you can see, the query is executed successfully for me, but the table is not created yet. Because we have selected the master database and executed the query in books_db database, we can't see it yet. That's why we have to select books_db now. And if we click on the refresh button, the table will be created. Now, let's create another table in our books_db database. We run the following query. Create table student1, open brackets, ID int primary keys, name varchar open brackets 30 close brackets, last name varchar open brackets 30 close brackets, year int close brackets semicolon. After running the query, we will select the books_db database, and then we will click on Execute Query. Again, don't forget to click on the Refresh button. Let's open the books_db database and open in the Tables folder. We can see that the table dbo.student1 is created here. Now, if we open the table and click on Column folder, we will see ID, name, last name and year here. Now, if we want to add another column of the year the students passed, we will run the following query. Create table books, open brackets, ID int primary keys, name varchar open brackets 30 close brackets, last name varchar open brackets 30 close brackets, year int close brackets semicolon. Alter table student1, add pass_year int. Now, let's select the newly added query and click on Execute. After execution, we will refresh and open the columns. There, you can see that another column of past year was added in the table student1 of the database. It's null because we haven't submitted any data in it up until now. Remember, if you want to execute any query, you have to select it. Now, let's try deleting the column. Run the following query. Alter table student1, drop column pass_year. Select the query and click on Execute. The column will be deleted from the table. So this is the process to create and alter tables. Next lecture will be about wanting to apply limitations on tables.